Good afternoon, ma'am.
Good afternoon. I'm just waiting for other students to join. We will start in 2 minutes.
Yeah, ma'am.
Okay.
Yeah, ma'am. We will wait.
Is my screen visible and am I audible, right?
Yes, ma'am.
Okay.
Yeah, yes, ma'am. Yes, ma'am.
We
It
will
is visible
start
and we
in
are audible.
next few minutes.
Okay, ma'am.
Do
Ma'am,
you
I
have
just
any
want to share
doubts
one
from
thing.
earlier class?
No, ma'am. I didn't attend the earlier class, but I checked in YouTube. Completely, I go through the videos. I just really enjoyed the session, ma'am, because
Okay.
it is a wonderful session that we need.
Good.
I have a lot of doubts in various settings that was cleared in that session itself.
Okay. Nice.
Uh, Once again, thank you for your presentation, ma'am.
It's my duty. Okay. Let's start the class. Good afternoon,
Yeah.
everyone. I am Rakhi Yadav, PhD Chemistry at IIT Bombay. I'm your PMRF and NPTEL TA for Pericyclic Reactions and Organic Photochemistry course, which is conducted by NPTEL and whose course instructor is Professor Sankara Raman from IIT Madras. So, students, in week 1, we have covered electrocyclic reactions. In week 2, we have covered cycloaddition reaction involving 4 plus 2 cycloaddition and 2 plus 2 cycloaddition. In today's class, we are going to cover 1,3 dipolar as well as some higher order cycloaddition reactions. So, as we have discussed in previous class that cycloaddition reaction is a two component reaction in which two components are going to add in a cyclic way. So, in 4 plus 2 we have covered important diels alder reaction. In today's session we are going to cover dipolar cycloaddition as well. And in 2 plus 2 students, this paternobuchi we will cover in photochemical reaction. Paternobuchi is cycloaddition reaction between your olefin and your carbonyl. 2 plus 2 cycloaddition between two olefins we have covered in last class. Today we are going to see 2 plus 2 cycloaddition reaction between an olefin and ketene. If you have attended my last class, have you solved this question?
Yeah, ma'am. I have solved this question because
Okay, so
in that first one,
let's start solving this. So students, this is your cyclopentadiene. Base is given. Base, what will do? Base will abstract proton from this, right? So what will form here? Cl, Cl negative. Base will negative charge will come down and will knock off this chlorine, and what you will get? Ketene type of intermediate. Not type of, exactly ketene. Is this clear? Now I have told you in last class that tell me the condition under which um, 2 plus 2 cycloaddition of ketene will take place. I have asked you whether ketene will undergo 4 plus 2 or 2 plus 2 with an external olefin, right? So in next slide I'm going to make you understand that why ketenes undergo 2 plus 2 cycloaddition only, and which take place in presence of thermal or photochemical. Student, thermal.
thermal condition.
Thermal condition. In general, in last class we have seen that simple cycloaddition between two olefins take place under photochemical condition. We have seen there the reason, a bifrontier molecular orbital approach. But today I will explain you why it can't undergo 4 plus 2 cycloaddition. But before that, let us do this question. We have to do 2 plus 2 cycloaddition between this ketene and olefin. Now let's talk about its regioselectivity. There are two options, student. Either I can make it like this, or I can make it like this. A and B. Can you tell me which intermediates are relatively more stable, A or B?
I think yeah, ma'am.
A. Why?
Ma'am, I thought is it a bridged complex? Confirm.
No. You thought ki 2 plus 2, sorry, 4 plus 2 cycloaddition will take place between this ketene and this cyclopentadiene,
Mm-hmm.
right?
Yes, yes, ma'am.
No doubt everyone will think like this whenever you will see diene and your this ketene. You will first thing which will come in your mind is that do 4 plus 2, but 4 plus 2 cycloaddition between ketene and your cyclopentadiene is forbidden. Why, we will discuss, but for now you have to think like this, that you have to do 2 plus 2. So for doing 2 plus 2, students, here your negative charge is stabilized by this allylic position, but your positive charge is not stabilized, right? But in this case,
Okay.
your negative charge, here there are no so much hyperconjugation, only two hydrogens are there, right? But this positive charge can be stabilized by this. So remember this thing always, whenever you are doing 2 plus 2 cycloaddition by taking one partner as this cyclopentadiene, go via this charge in order to make correct regioisomer. Okay, among these two possible, where positive charge will come and where negative charge will come. I have already told you I am making these charges only to make a correct regioisomer. Otherwise, these reactions go in a concerted way. Okay. Now tell me, student, you have to take this olefin in picture. Here what charge will come and here what charge will come.
I think on the halogen side it is negative and
And here
the
positive,
double bond
right?
side it is
Right?
yes.
Now,
Yes.
in order to make a compound completely, this is your stable intermediate. Okay. Now positive have to go to this side. Let me make here. Positive will go to negative side, means ClCl, and this will be like this. Understood how to draw 2 plus 2 product of cyclopentadiene and ketene? First, in these two
Yes, ma'am.
intermediates, you have to decide the intermediate which can stabilize your carbocation. Here, carbocation is not stabilized because double bond is 2 carbon away. It means it is not allylic, right? But in this case, your carbocation is stabilized. You have drawn this in ketene, give this side as positive, this is negative because this is your electron deficient center. So positive charge will combine with negative and positive charge will combine with this carbon. Till this point, I think everything is clear. Okay. So your A is this. Can I rub this part?
Yes, ma'am.
Okay. 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 Now tell me electronic configuration of zinc.
Zinc D10, ma'am.
Zinc D10 is, it means zinc have enough electrons, right? So what it
Yes,
will
ma'am.
do?
Yes, ma'am.
What it will do?
It does not affect, ma'am. If it is enough electron, it does not affect.
But in organic chemistry, whenever you come across zinc reaction, zinc in presence of acetic acid, what it will do? It will donate one electron to your oxygen. Why? Because this bond will come here and one Cl minus will knock off. In that case, what zinc will do? Zinc will give its one electron to oxygen. When zinc will donate one electron to your oxygen, zinc itself will become zinc positive plus one electron. Is this thing clear? And this electron is given to this oxygen. And one Cl minus has been knocked off. So final what you will write here. If you have not understood, please ask me again. Okay. First, just let me explain. Oxygen is having positive charge here because bond is like this. O zinc, zinc positive and Cl negative. So O zinc Cl. Clear? Zinc valency is complete. And
Yes, ma'am.
huh, and one chlorine has been knocked off, right? Till this point, clear that zinc has given one electron to oxygen. Oxygen lone pair, this pi bond will break and knock off one chlorine, right? Now it is like enolate form, and your acetic acid is also there. So it will come back, and this position will be protonated in presence of acid. And what you will get? Double bond O Cl. Okay. Again, in your reaction medium, zinc is there. Again, it will give one electron to this oxygen. And what it will form, student, at finally? Double bond OZnCl, and at last you will get ketone only. So what zinc acetic acid has done here? Removed those two chlorine atoms. Clear? Clear or not?
Yeah, ma'am. It is
Okay.
clear.
Now H2O2 is there. Okay. MCPBA H2O2. What role they play? If there is olefin, they tend to form epoxide. If there is ketone, they tend to make ester by Baeyer vinegar oxidation. Okay. So both the possibilities are present in our system. This have ketone as well as this olefin. But you can see that this is four-membered ring, right? So
Yes.
anything which can release this strain will happen. So among these two competitive reaction, Baeyer vinegar oxidation will take place, and what you will form as your B product as
Uh, one ring is extended ring, ma'am. The oxygen inserted in between. It
I
is
could
before the
I
double
couldn't
bond row.
I couldn't get what you have. Just wait. O.
For Bayer villager, I think the double bond row, before the double bond row, oxygen is inserted in the ring.
Uh, could you write in
Yes,
chat
yeah,
box?
can you able to hear me, ma'am?
I'm able to hear you, but I couldn't understand what you have asked.
Yeah,
Just
ma'am. In Bayer villager, the oxygen is inserted,
yeah,
oxygen atom is inserted, and the ring is extended
huh?
to the five-membered
Yes.
ring. That's what I'm telling.
Okay, okay, sorry. And now you may think, ma'am, which side I can insert this oxygen? I can insert either this position or this position, but this is tertiary. See, one, two, three, tertiary center, and this is your secondary. So among tertiary and second, which is at which side oxygen is inserted? Tertiary side. Okay. For that, your homework is study about Baeyer vinegar oxidation. Okay. What is this? And another thing which can you do is read migratory order there. If not understood, you can ask me next class. Okay. I hope this question is clear. In this question, two things were there. First, you have to decide either you will do 4 plus 2 or 2 plus 2. Cycloaddition with your ketene. Okay? Okay. And you made this A product. Now you have to think what zinc acetic acid will do. Zinc will donate electron to your oxygen and will knock off these two chlorine atoms. In second, H2O2 is there. Now you have to think whether you will epoxide this olefin or you have to do Baeyer vinegar oxidation. So it's good that you are doing Baeyer vinegar oxidation in order to remove that ring strain. Now next slide I will make you understand why ketenes can't undergo 4 plus 2 cycloaddition. You please write in your notebook ketenes can't undergo 4 plus 2 cycloaddition. They can only undergo 2 plus 2 cycloaddition, and that also in presence of thermal condition, not photochemical condition. Okay, so let's understand. This is your ketene, right? In order to make one pi bond, you all know that you have to do collateral overlapping. because sigma bond forms via head-on overlap. In order to form your pi bonds, you have to do collateral overlap. Collateral overlapping means they have same sign, yes or no? And this C double bond O pi orbital, how they can form perpendicular, students? Because can you tell me hybridization of this carbon? This is sp, right?
Yes, ma'am.
Hmm. So in order to have that overlap, it is like this. But you know that only this part is going to take part in your cycloaddition, whether it is 4 plus 2 or 2 plus 2, right? So we will talk about this part. Okay, let's make clear. Now tell me, if there is ethylene molecule, what it will in thermal condition, what it will be its homo, psi 1 or psi 2? I'm asking in thermal
Psi
condition,
1, ma'am.
psi 1. Very good. Psi 1 and orbital sign will be same or different?
Same, it is same.
Same. Good. Okay. And in 4 plus 2, what will be your homo?
HOMO will be Psi 2 and LUMO will be Psi 3 for the four electron system.
Okay. So that thing is clear, right? Just let me rub here. Erase this. Huh. Student, why I am making like this? Because you understood by this convention that this pi bond and this pi bond are two perpendicular, right? So I have drawn it like this. These are your pi bonds of C double bond C, and these are your pi bonds of CO, right? These. But we are only concerned about CC. Now let's check its bonding interaction. So this is your HOMO in case of ethylene, right? So let's check number of bonding interaction. This is your bonding interaction or anti-bonding? Bonding.
Bonding
This
that's
anti-bonding.
anti-bonding.
This anti-bonding. And now here, this is your positive, student. Anti-bonding. This is your bonding. Now tell me total number of anti-bonding and total number of bonding interaction.
3 anti-bonding and 2 bonding.
Two bonding, right? Now let's check here. This is your 2 plus 2 with ethylene, and this is case of your 4 plus 2. This is psi 1 of ethylene. This is psi 2 of your diene. Right, students? And one more thing is left here. Wait. In this case, bonding interactions are only two, right? So we can draw another possibility also. You have to write both the situation. I think you have written that. If I made it like this, negative, positive, negative, positive, right? So now what will be the case? This will be your anti-bonding. This will be your bonding, bonding, positive, positive, anti-bonding. Can now you tell me total number of anti-bonding and bonding interactions?
Two anti-bonding and three bonding.
Two anti-bonding and four bonding, right? So in total you have results here as plus 2, right? Now let's see here. Bonding, anti-bonding, bonding, anti-bonding, anti-bonding. Here students, number of anti-bonding interactions are more than your bonding interactions, right? That's why 2 plus 2 cycloaddition is more facile. In 2 plus 2 cycloaddition, I have told you both the condition. You can keep your orbitals like this and reverse also. In that case, you were getting anti-bonding interactions more. But it can also flip in this form also. But when you will draw other possibility in this case, in that case also you will get number of anti-bonding interactions more than your bonding one. This is only frontier molecular orbital approach to understand this why ketenes didn't undergo 4 plus 2 cycloaddition. You understood or you got confused in last? I will explain you again.
Well, please explain, ma'am.
Okay, okay.
Yes,
Okay,
I
I
was a
can
bit
explain
confused.
again. Let's erase this one. Actually, here two perpendicular pi orbitals are involved, so it is quite difficult for making you understand. But let me try once more. I was saying, student, this is your ketene, right? You have to take ketene is your electron deficient because it is attached to C double bond O, right? So this will be your LUMO. In cycloaddition, we see homolumo and we see that interactions. More the bonding interaction, more facile will be your cycloaddition, right? So you have to take LUMO of your ketene and HOMO of your diene or your olefin. We have to see both the condition. First, we are looking at 2 plus 2 cycloaddition between your ketene and simple ethylene. So in that case, you have to take HOMO of your olefin and LUMO of your ketene. Understood? So this is your LUMO. And HOMO, you have only told me that HOMO is psi 1. Psi 1 will be having same sign. These are your orbitals of your C double bond C of your ketene. See, positive, positive, negative, negative. And these perpendicular orbitals involved are of C double bond O. Understood till this point?
Yeah, ma'am, it is understood.
Now I am checking total number of bonding interaction and total number of anti-bonding interaction. So positive, negative, anti-bonding, negative, negative, bonding, negative, negative, bonding. This is your bonding. Clear? Now if we see this is your olefin, simple ethylene one. Okay. These are orbitals of your ketene and these are orbitals of your olefin. Now see. Positive, positive, bonding and positive, negative. Bonding or anti-bonding?
Anti-bonding.
Anti-bonding. Now I was asking you, Please tell me total number of bonding and anti-bonding interactions. Tell me.
Four bonding, ma'am,
Four bonding, one, two, three, four, four
and two
bonding,
antibonding.
and two anti-bonding. Till this point, everything is clear.
Yes, ma'am, it is clear.
Okay, now let's come to this situation. Okay, here, student, this is your bonding, clear, this is your anti-bonding. In a similar fashion, this is your bonding and this is your also bonding interaction. I hope everything is clear this point, till this point.
Yes,
And
ma'am.
these both are your anti-bonding. So now tell me three, okay, actually we missed here this one bonding, right? So I was wrong there. You have not corrected me also. Huh. So now tell me total number of bonding interactions are in this case 3 and total number of anti-bonding interactions are 3. Net interaction
Three.
is 0. Okay. Nothing is there in this case, nothing is positive. Net interactions are 0. Yes or no? So that's why
Yes, ma'am.
student 4 plus 2 cycloaddition is not facile. Now you may think, ma'am, can I draw here negative, here positive, and here positive, negative? You can make that structure also. There also you will get zero bonding interaction in total. Okay. Such as one positive and one negative cut each other. In a similar fashion, here there are net zero interactions, but here two in positive. Yes or no?
Yes, ma'am.
It is quite difficult to understand, but it is only explanation which is given in textbook कि why ketenes undergo 2 plus 2 cycloaddition, not 4 plus 2. You have to take LUMO of your ketene, HOMO of your ethylene. And why, and here from here one reason is also there कि why 2 plus 2 cycloaddition between ketene and olefin take place in thermal condition. Why? Because in photochemical condition it will be like this scenario. Yes or no? Because in photochemical
Yes, ma'am.
condition psi 2 will be homo, and in that case also you will get zero bonding interactions net. So that's why 2 plus 2 cycloaddition always take place between ketene and your olefin, and that too in your thermal condition. Understood?
Yes,
You
ma'am.
again go through this slide, and still if it is not clear, I can explain again in next class. Okay?
Okay, ma'am. Now it is clear, ma'am.
Okay, good,
Actually,
good.
now only I understand.
So let's start some questions solving. So student, in this question they are asking suggest starting materials for preparation of the following compounds. So they are asking how you will make this compound. Whatever reactions you have studied till now, among that tell me which reaction can you use for making this compound. Can you use electrocyclic reaction?
Yes, ma'am. Electrocyclic ring closing reaction.
Are you sure? If you
Yeah,
are
ma'am. I'm
taking
sure.
electrocyclic reaction, which component you can take?
I think this is octatetraene. I think so. I don't know exactly.
Okay, but one thing you should keep in your mind is, student, that whenever you are having this diene and dienophile, right? What product you get? But good that you have even you at your home. Please try to make this compound by electrocyclic reaction, and if it is possible, please tell me in next class. Okay, but whenever
Okay, ma'am.
you come across this cyclohexene, first thing that that should come in your mind is that it has been formed via 4 plus 2 reaction. Yes or no? Because this bond can go here, this can go here, and this can go here. And if you draw retrosynthesis, you will come across this. Yes or no? So how can you design this molecule? If you can use this diene and Dinophile is your benzoquinone. Yes or no?
Yes, ma'am. Now I understood.
Huh.
I remember now.
And this stereo is clear why these two hydrogens are cis, because these are cis in dinophile as well. So in that way you have to think that how can you design starting material. You have to see via this 4 plus 2 cycloaddition which motif is forming, right? Cyclohexene is forming. Good. And one more thing for electrocyclic reaction. Ki let's say you are given this molecule. Okay. Now it is not cyclohexene, but you know very well that this bond can break. Now you can think of your electrocyclic ring opening. Okay. So what things are necessary for your electrocyclic ring opening, student? That something should be in conjugation. Yes or no? But here there is no conjugation of this type. So only possible outcome is your Diels-Alder reaction. So I am again giving you hint for B part. This will also form from Diels-Alder reaction. One thing is missing. Sorry for that thing. It is like this. Now tell me how you will form this compound. Take 1 minute time and think. And please remember that thing, that for Diels-Alder reaction, your diene should be electron rich and your dinophile should be electron deficient. Otherwise, electronic requirements will not come. Think about this and tell me what will be your diene and what will be your dinophile. And how can you draw its retrosynthesis? Let me explain again. Break this bond, and this. One ethylene will be as it is, and this will be your dye. Understood? Now tell me.
I think diol, ma'am. Is it right?
Huh? What you have formed?
Diol. To diol, I think so.
Okay.
Diol
First,
is
first you tell me either this
trans.
either this will be your diene, or sorry, not plus, or this will be your diene, and why? Now tell me. Among A and B, which is your possible diene?
Yeah, ma'am. Yeah.
Okay. You are saying this with respect to these ethyls are same side, right?
Same side.
And
Yes.
I have told you line rule in last class that whatever is own line,
Yes. On the line.
they will be having same stereo, right?
See.
Very good. It is clear. And one thing is also there, they are going in okay. This thing is clear. That we opposite and that thing we consider in electrocyclic reaction. Now tell me olefin. You are telling me that ma'am olefin will be this. Yes or no?
Yes, ma'am.
But student, whenever you are asked for this question, this answer is wrong. Why? Because I've told you for 4 plus 2 cycloaddition, your dinophile should be electron deficient. Because whenever it will be
See.
electron deficient, then only its LUMO can come down. So what will be your alternative? You take CO2 ET. Now your electron,
Okay.
yeah, now your olefin is electron deficient, yes or no?
Yes, ma'am.
Okay, now another question. You will take cis olefin or trans olefin?
Trans.
Exactly, because your reaction is stereospecific with your diene. Sorry, dinophile.
Mm.
They are cis here, but they are trans here. So, in order to overcome that problem, you have to take this. Okay. So, when you will do 4 plus 2 cycloaddition between these two, you will get your final product like this. Et Et, CO2 Et. Now tell me from your organic chemistry knowledge that how can you form this compound A to this B? What reagent can you add? Do you know anything about lithium aluminum hydride LAH?
Yes, ma'am. It is a strong reducing agent.
That can transform any or carbonyl compounds
Reduce.
to alcohol, right? So now
Okay.
you have to write on arrow
Yes, ma'am. Yes.
lithium aluminum hydride and you will get this product. You understood why can't
Ma'am,
you
why
take?
not sodium borohydride?
Okay, do you know sodium borohydride can reduce up to ketones? Yes or
I don't know
no?
exactly, but sodium borohydride reduces secondary carbon, right? Only in the presence of secondary and tertiary.
Let me explain you, student. Among lithium aluminum hydride and sodium borohydride, this can transform all compound. All compounds means ketone, aldehyde, amide, carboxylic acid to your alcohols. But NaBH or esters, mainly esters also. But your NaBH4 can reduce till ketones only. Why? Because it is least okay. Because it is less reactive. And now you should think in your mind. You tell me among ketones and among esters, which is more reactive for getting reduced? Okay, your LAH and sodium borohydride will give H minus, right? They are nucleophile.
Hmm.
You have which carbonyl will be more reactive, which is electron deficient, yes or no? So when
Yes, ma'am.
we compare these two students, this oxygen lone pair can push and can make this carbonyl electron rich relative to this your ketone. So among ketone and ester, your ketones are more reactive for this nucleophilic addition. Till this point, everything is clear. And your
Yes, ma'am. Now it is clear.
aldehydes are more electron rich than your ketone. Why?
Hmm.
Not electron rich. Aldehydes are more reactive for nucleophilic addition than your ketone. This you know from your 11th, 12th also. Because that CH3 is hyperconjugation, is showing here hyperconjugation effect, making your carbonyl slightly electron rich in comparison to your aldehyde. Yes or no?
Yes, ma'am.
Okay. That's why students. And now time to talk about which bond is more polarized among aluminum hydrogen and boron hydrogen.
Uh,
Aluminum hydrogen bond is more ionic, students, because electronegativity difference between aluminum hydrogen is more than your boron hydrogen. Okay, so if it is more reactive, okay, so if it is more reactive it can reduce everything, right? But NaBH4 is compared to LAH is less polar. So less polar means it will release this hydride slowly in comparison to your LAH, right? That's why it can. Okay. Why we talk about reagents? Why there is sodium borohydride, lithium aluminum hydride, zinc borohydride? Because if if in our compound there are two functional group, esters and aldehyde, esters and aldehyde, and you want only aldehyde to reduce, so you need some mild reducing agent which can react only with your aldehyde, yes or no? So, among LAH and sodium borohydride, sodium borohydride is least reactive. Okay. So, there is one least reactive thing, and now you have two things, aldehyde and ester. Which it will reduce first, aldehyde or ester? Aldehyde. Why? Because aldehyde is itself more reactive. If one thing is less, you have to make other thing more. Understood? If sodium
Yes, ma'am.
borohydride is least reactive, you have to make your carbonyl more reactive for nucleophilic addition. And among aldehyde and esters, aldehydes are more reactive for nucleophilic addition. I hope now you have understood.
Yes, ma'am. Now I understood.
And now you may ask, ma'am, why aluminum hydrogen bond is more polar? You check electronegativity difference between aluminum hydrogen and boron hydrogen. Okay?
Okay.
And then you can decide which bond is more polar. More the bond is polar, more easily it will release H minus for attack. Understood?
Yes, ma'am. Now
Okay,
it is.
good. Both the questions you have understood. How you can suggest starting materials for them, right? Okay,
Yes, ma'am. I
good.
understand.
So now tell me this question. A hint for this question I have given you in previous slide. Take 1 minute time and suggest me suitable starting material. Till then, let me find exact electronegativity bit of aluminium and boron. I am quite weak at memorizing electronegativity of aluminium 1.61. I hope you are solving. I will also
Yes,
solve,
ma'am.
you
Yes,
just
ma'am.
give one try. Huh.
Yeah.
Electronegativity of. So, aluminium is having electronegativity on Pauling scale 1.61. Boron is having 2.04. Hydrogen is having electronegativity of 2.1. Now you can easily differentiate that aluminium and hydrogen electronegativity difference is more, right? Whenever you are having A and B bond, let's say electronegativity difference is more. Let me give you class basic example. One chocolate is there, okay, you and your friend is there. More the love for chocolate is difference in you and your friend, more this bond will break, yes or no? Let's say
Yes,
if
ma'am.
if you and your friend have similar electron difference between chocolate, you will do half and half, right? So this bond will be strong. But when this bond is more prone to cleave, when one is having more electron affinity, right? So, in a similar fashion, aluminium is having more electronegativity than your hydrogen relative to your boron, right? So, that's why aluminium hydrogen bond is more polar, and that's why this H negative is more prone to deliver in case of your lithium aluminium hydride relative to your sodium borohydride. Clear the concept?
Yes, ma'am. Yes, ma'am. Now it's clear.
Good. Now, tell me the answer for this question.
Ma'am, for A, the bond is broken and
Which
forms a
type
ring
of
opening
reaction?
reaction with stable bond.
Electrocyclic or cycloaddition?
Electrocyclic, ma'am.
Very good. You can draw its another form. It is there to confuse you. You can write it in this way, okay?
Yeah, ma'am. I draw this form. Yeah, I
Good.
draw this form only.
Good, good.
Okay.
pH, pH. 4 pi system students. Heat is there. Which type of rotation will take place? Cone or disk? Cone. Yes or no?
Contradiction.
Okay.
Yes, yes,
These
contradiction.
are trans. Cone rotation is there. So after reaction also they will be opposite only. So how can you make that
Yes.
product?
pH on the upside and one pH on the straight.
Very good, very good. Like this, right? So this is your A. Now in second
Ma'am, I
reaction,
think this is for cis, right? Ma'am, just a
this will
minute.
be
Sorry
like
to
this.
interrupt you.
Sorry for that. And now your B product will be your diels alder product. So this is a reaction electrocyclic followed by your diels alder reaction. So what product you will get? Now tell me stereo of P. Wait. One thing I think I have made it wrong.
Ma'am, that
Yes.
pH will be on the
Yes. Huh.
opposite side, ma'am. That's what I'm telling. Because it is not cis.
Wait. What pH are on opposite side, right? They will be opposite only. So, but product is your. Now, is this product correct?
Yes, ma'am, it is correct.
Now, your last
The
question from
double
this
bond.
slide is tell me relative stereochemistry of all the groups. They will be on, everything will be on same stereo, right? Which, which, and if there is any doubt in stereochemistry, ask.
Ma'am, I have a doubt, ma'am.
Huh,
Here in
ask.
the initial reactant, the both pH is on the opposite side.
Huh?
So
Because
how can it possible that pH on the upside and
because
pH
now you
one
are
pH on the
mixing electrocyclic rules with your cycloaddition rules. In electrocyclic we
mm,
were looking at that opposite and same, right? But in 4 plus 2
yes.
how we are looking at stereo? By that line rule. Everything that is on line and left to it will be having same stereo, and everything that is right to that they will have opposite stereo. Okay, so these hydrogens will be inside. So everything will be at same.
Okay, ma'am, that is okay. For the A product, I'm asking ma'am. So you said that on the line, if it is on the line, then it is on the same stereo for the A product in the down. Yeah, that one.
This product came from your electrocyclic reaction, student, right?
Okay.
And
Oh,
this is your desolder product. In both the case,
okay.
in both the case, we are deciding stereochemistry by two different things. Don't mix them. I was saying that only.
Okay, ma'am. Okay. Now I understand. Yeah.
Okay, good. Okay. So in this question, you have to tell me plausible mechanism for this conversion. Have you studied Nazarov electrocyclization in Sir's lecture? Nazarov. Whenever
No,
you
ma'am,
are
I cannot.
having no, okay, then to I have to tell
I
you.
cannot remember that.
Okay, no issue. Let's say students, you are having this type of system and acidic conditions are there. It will protonate this, right? And under heating condition, whenever you are having this type of system, electrocyclic ring closing reaction will take place. So what you will form? Negative, sorry, you will get this. And at last, whenever you are left with carbocation, two reactions are possible. One is nucleophilic substitution, another is elimination. When nothing is there, Just eliminate the corresponding hydrogen. So this will be your product. And this enol form will tautomerize to its keto form, right? And you will get this. Understood? What is basic Nazarov cyclization? I have told you in brief. Electrocyclic ring closing of these type of system is referred to your Nazarov cyclization. Clear? Still
Can you
not
please
clear.
explain one more time?
What you are saying? Could you please repeat?
Uh, yeah, can you please explain one more time?
Yeah, sure. See,
Yeah.
this is your cyclopentadienyl cation, right? Just understand by this. Okay. How ring form will take place? You go here, okay, and this charge will go there. This positive and negative, because positive will come here. This positive and negative have met and resulted into formation of this double bond, right? And this positive is
Yes,
neutralized
ma'am.
by negative of this. So you have made new sigma bond and you are left with this positive charge. So your charges are going like this. Now you have understood how I am closing this cyclopentadienyl cation.
Yes, ma'am. Now I understand.
Now you are left with this positive charge. Now this can undergo two reactions, either elimination or nucleophilic substitution. That depends on condition. So I was telling this is your Nazarov cyclization. Clear? Okay.
Yes, ma'am.
If clear, tell me answer to this question. I hope you have written this mechanism. No, no issue. I will make again. We will come back to this question after 2 minutes. Before that, tell me if you are having this type of system. There are two possibilities. One is this, and one is this. Oh, sorry. Clear? First, tell me, are you clear if we are doing,
Yes, ma'am. Yes, ma'am.
let's say it is thermal
Now it is clear.
condition is given and we have to do Nazarov cyclization. Nazarov is a name given to electrocyclic ring closing of this cyclopentadienyl cation. Okay. Now I am asking, if you have to close this ring, you have these two possibilities, A and B. Now tell me under which condition your carbocation is stable, under condition A or B? Under condition A, student. Why? It is allylic as well as having three hyperconjugation. Yes or no? But in this case, it is allylic but having only two hyperconjugation. It is having three as well as two hyperconjugation. Total five. Clear? Do you know what is hyperconjugation?
Yeah, ma'am. I am, ma'am.
You know.
It is
Very good.
stabilized by the
Huh.
neighboring
So here
hydrogen.
three adjacent hydrogen, 3 and 2, total 5 hyperconjugation. Here only 2 hyperconjugation. So your A product is correct. So I am telling how you have to make correct regioisomer in Nazarov cyclization. Okay.
Yes, ma'am.
Okay. If everything is clear, start solving this question. TiCl4 is your Lewis acid. It will coordinate to your carbonyl and it will form your cyclopentadienyl intermediate. Let me redraw for you.
You have to take the double bond O carbonyl and it produces positive. On the
Hmm.
left hand side, on the left hand side,
Wait.
we have extra hydrogenated. So
Can I draw it like this? Actually, network is not. Just let me check my network. This pen is not working. Let it. Huh. I was saying you have to draw it like this: double bond, and carbonyl carbon next to carbonyl is attached with your ethyl, and this is your methyl, right? They are on same side. You have to draw exactly as given. Okay, and this is your methyl, and you have to draw other part is CH2, your phenyl ring. OMe is meta to your this. Clear everything? Now, at which side you
yes,
will make that carbocation after that ring closing? Left side or right side?
left side now
Why?
because it is stabilized by more hydrogen.
Are you sure?
Hyperconjugation will occur on the
Here
left
you
side.
will be having three
Yes,
hyperconjugation, but here you will be having two hyperconjugation.
to
Forget about
hyperconjugation.
this. I'm just talking about this. Methyl is having three protons, right? Let me draw for you, then you will
Yes, ma'am.
understand. Oh, I'm writing TiCl4 by Lewis acid, ethyl. Some network issues there, that's why it is lagging. Hello, am I audible, right?
Yes, ma'am. You are
Okay,
audible.
okay. And now, student, here there will be your carbocation, right? And along with that, you have CH2, and your phenyl ring. Now, what can be, what is possible here? Tell me.
Ring closing reaction occurs, ma'am,
Just give me one.
from the positive.
Ring closing. What type of reaction is that? Have you studied electrophilic aromatic substitution reaction?
Yes, ma'am.
So now this aryl ring will trap this carbocation and you will get this, right? This enol will transform to, after tautomerism, it will transform to your ketone. Okay. And this ring will trap your this carbocation like this. I hope you have understood.
Yes, ma'am.
Good. So can we move ahead? Clear now everything?
Yes, ma'am. But what about the stereochemistry, ma'am? In this?
Okay, stereochemistry. Good question. These end orbitals are matching, right? They are trans to each other or cis, matlab they are going in opposite direction or in same direction.
Ma'am, initially it is trans, ma'am.
Trans. It means they are
Then
opposite side, right? How many?
yes, they are opposite.
Which type of system it is? 4 pi or 4n plus 2?
4 pi, ma'am.
4 pi. Very good.
Yes, 4.
4 pi under thermal condition undergo which type of electrocyclic ring reaction? Which type of closure? Disk rotation or cone rotation?
Thermal condition conrotation.
Cone rotation. Very good. Opposite cone. But then, wait a
Yes.
minute. This is your methyl. That will be your cis to your ethyl, right? And this is
Mm.
your methyl, which will be your cis. These are correctly. Hydrogens are going in opposite directions.
Yes.
And this is your cone rotation, right? But in that case, so
Mm.
they should be trans. One thing we are doing it here wrong, or we are right. Yeah, correct, na student, correct. This is your methyl, right? And this is your R group. They both are opposite. Yes or
Mm.
no?
Yes, ma'am.
As per
They
our
both are.
as per our mnemonics, they should be trans. So yeah, they are trans. Methyl is at dash, and this is at wedge, because if hydrogen is at dash, this group will be at wedge. So these group are opposite, right? And they are opposite here as well. Yes or no? One is going in this direction and one is going in this direction. Now stereo is clear.
Ma'am, I have a doubt in hydrogen. Is that if it is a trans, then trans isomer will come, right? For the final product. So how it can be on the
See, okay, let me explain you. You are seeing relative stereo of these two, yes or no?
yes, ma'am. Yes, ma'am.
Okay. This methyl and this hydrogen are going same side. If I draw hydrogen here, oh sorry, let me draw for you. If I have to draw hydrogen, I will draw it like this. This methyl and
Yes,
hydrogen
ma'am.
are going in same direction. So after cone
Yes,
rotation, they
yes,
will
ma'am.
be in same, and they are same. That's what I was explaining you.
Okay, okay, ma'am. Okay, now I
Clear na
understand. Yeah,
now?
yeah. Now it is
Okay.
everything clear.
Good. I hope everything is clear in this slide. In this slide, you have
Yeah.
we have studied Nazarov cyclization. Nazarov cyclization is electrocyclic ring closure of your cyclopentadienyl cation, right? Here, that cation is getting trapped by your aryl ring. Good. First time you have studied this reaction, and you have done most trickier part of this question, of this reaction. Okay. I thought ki you have studied in sir's lecture. That's why I have put this question here. Okay. Tell me, for the synthesis of this molecule, which starting material you will take for this alder reaction?
Give me a second that I will check which one is
Okay, take
possible.
your
A
time.
is omitted, ma'am, because
You take 1 minute
A is
time
omitted.
and then come with correct answer. Okay, take your 1 minute time.
Mm, mm.
A is not correct.
Okay. Yes. Ma'am, option D, ma'am. Option D, last one.
This one. Are you sure?
Yes. Yes, ma'am, I'm sure.
Why not B?
Because the number of carbon is increased in that B.
Exactly, exactly. So option D is your correct answer. So these will be your
Yes.
bridging carbons. Okay, and this is your dinophile,
Yes.
and that is this.
Yes.
Good. Now, in this question, in the two-step reaction shown below, identify the correct combination of product 1 and 2. First reaction is which reaction, student? Electrocyclic or diels alder reaction?
Diels alder reaction, ma'am.
So you make product, first make correct product, and
Actually,
then let,
for
yeah, ask.
this one, I have doubt, ma'am. So
Huh.
whether it undergoes endo or exo, which one is correct? Because I don't know
Endo, and
how
I will tell you why endo.
endo.
Okay.
Mm-hmm. Okay, ma'am.
Now start solving and let me tell you role of N-bromosuccinimide. It gives Br positive. Okay. So think about
Mm.
the think from that angle. Okay. Take 1 minute
Okay, ma'am.
time and solve. Okay. In first question, you are saying that you will be getting COH, right? So COH will be endo, and you know that the same reason which I have told you. They will be inside, right?
Always, yeah,
Second, due
yes.
to secondary
Yeah,
orbital interaction. Now at second step they are saying N-bromosuccinimide is there, so they will form here bromonium ion
cyclic.
intermediate. Now since this carboxylic acid is present at downside, it will attack it and open this bromonium ring, right? So among A, B, C, D, which two option I can delete?
Option A and B, last option. Option A and B.
You delete easily. Okay. Among these two
Mm.
options, this bromine is at this bromine is, see, your carboxylic acid is opening this ring from downside, right? So in which option it is at downside?
Option
Yes. So among C and D, which option is more appropriate?
C.
Exactly. This is your more stable compound. So C option is correct. Good. Okay. Quickly tell me
Ma'am, that
answers.
bromine,
Bromine.
actually, I have a doubt. That bromine will form the transition state, right? Cyclic transition state.
That will be in same side, na?
Mm-hmm. Okay. Okay.
That
Yeah. Okay.
ring can form from same side. If it is breaking from
Mm.
downside, bromine will go above there, right?
Okay. Okay. I now
Huh.
understand. Yeah.
Quickly solve these questions. Okay. There are too many questions on this slide. I am also solving with you. See, students, one thing you keep in your mind is whenever NBS N-bromosuccinimide is given in H mu condition, it will release bromine radical. Okay, but whenever NBS is given in normal condition or aqueous condition, it will release your Br positive. Right here, Br it is given in presence of light. So obviously in presence of light at allylic radical it will form your allylic bromine. Yes or no? So, potassium tert butoxide. It is very strong base. Base will abstract proton from here, come there, knock off this bromine and will form your cyclohexadiene. Okay. Cyclohexadiene is there. Dinophile is there. 4 plus 2 reaction will take place, students. C double bond O, C double bond O. Clear? So this will be your product in case 1. I hope it is clear.
Yes, ma'am.
Okay. You also got this product, right? I'm making again. Wait. Clear? So this is your product 2. Now tell me second. Vinyl
Ma'am,
grignard is there,
sorry to interrupt.
aldehyde is there. First, which reaction will take place? C,
Grignard
OH
reaction.
and attack of this vinyl grignard. Yes or no? What is the role of
Yes.
MnO2?
It is the oxidation
Exactly. So it will
solution.
make here carbonyl. pH, your dinophile is ready. Yes or no? Product is given.
Yes, ma'am.
Now you have to tell me which diene they have taken in order to get this product. Cyclopentadiene. Yes or no? So third is
Yes.
your cyclopentadiene. Clear? At last
Yes.
MCPB is there. What it will do? Bare vinegar oxidation or your epoxidation?
Bayer release your oxidation.
No, no, no. Among
And for MCP,
epoxidation and bare vinegar oxidation, epoxidation is more facile. But in which cases bare vinegar
okay.
oxidation will take place? In cases where ring strain is releasing. Understood? So
Okay. Yeah, ma'am. Okay.
in that case, you will get simply your, and that epoxide will form above side, bridge side, because bridge side only one carbon is there, and you will get your COPH. Understood this problem? I think now you can
Yes, ma'am.
solve electrocyclic, cycloaddition question and their combination, right? So if you
Mm.
understood, tell me the third, in third question what will form.
In this C double bond, that C will be produced, ma'am, and that Br there
Okay,
will be getting the
zinc
zinc
is
product.
there. What is the role of zinc? First, tell me what is the role of zinc.
It el it eliminates the halogen
Exactly,
because it donates
and
one
it
electron.
inserts between carbon and halogen bond, right? So what it
Yes,
will do?
yes,
If I make it like this, now your confusion will be clear.
mm.
CH2Br, CH2Br, right? Now zinc is there, students. What it will do? This negative charge will go there and it will go there. Okay. And what it will form? I hope you are clear that I am getting this.
Yes, ma'am.
Let me
Yes, yes,
explain you. First, zinc will insert between your C and Br, making it carbanion. That carbanion will go above here, carbanion will go there. It will come here, and that negative will knock off this bromine. Understood? Whatever negative charge will come, it will go there and knock off your bromine, right? And you will get this. Clear? Your diene is ready. Your dienophile is
yes, ma'am.
ready. You have to do 4 plus 2. I hope you will make final product from here. Right?
Yes,
All these questions are clear, whichever are there on this slide.
yes, ma'am. Ma'am, can you write the final product? It is that OMe is formed upon the ring formation.
Okay, let me. I'm writing here. Okay.
Yes, because I want to check the final product.
Yeah, yeah, yeah. Okay. Now your COCH3. Which stereo I should write? Clear? So this is your final uh, actually, wait. Now clear?
Yes, ma'am. And why it is always this, ma'am?
Which says?
Because all is right. MB and CHS.
You forgot line rule
The
means.
final one.
This is your electron withdrawing group. You have to keep inside
Hmm.
it in order to have secondary orbital interaction. On line and left to line, all are having
Okay.
cis stereo.
Yeah, yeah, yeah. Okay, okay. That we need to include in this.
Uh,
Yeah, okay.
you
I
just
got it.
revise and whenever you will do enough question for this, na, then that thing will be always clear.
Okay.
Understood? Okay,
Yes, ma'am.
let's go. Okay, solve this question.
Now it is an intramolecular reaction, right?
Yeah, intramolecular.
Yeah, first form the diene, ma'am.
Correct. Then
That ring opening occurs.
that means you understood that
Uh,
one funda is that whenever there is benzene fused with cyclobutane, electrocyclic ring opening will take place. Okay. So at first
yes,
instance, you
electrocyclic
are
ring opening and
saying
the
that.
butene.
uh, so at first instance, you are saying that, ma'am, you make this product clear, and above that,
Yes.
sorry for my bad handwriting.
Hmm.
Eraser. Wait. Now, what reaction can take place?
Now 4 plus 2 addition.
4 plus 2 or 6 pi electrocyclic ring closure?
Yes, it is 1, 2, 3.
No,
6 by
I was
electrocyclic
just
ring close.
confusing you. See, 6 pi electrocyclic ring
Yeah,
closure you can do
it is not possible, ma'am.
whenever
Ma'am,
everything is
that
there
6
in conjugation, right? Like this.
conjugation.
But here
Yes,
they are not
it
conjugated.
is not
Here,
possible. Hmm.
intramolecular diels alder reaction will take place and lead to this product. Understood?
Yeah, okay.
So this question was about electrocyclic ring opening followed by electrocyclic ring, sorry, diels alder.
Diels and
I hope everything is clear in this question.
yes, ma'am.
Stereo,
Yes, ma'am.
stereo,
Stereo,
stereo. You decide by yourself whether it is correct in this question. If not clear, tell me at the end of the lecture. Okay.
sure, ma'am. Okay.
They are trans here. Now think, is it correct that they are trans? Okay.
1,
Okay.
2.
Okay. Do you know the role of first reagent? If not, I can tell you. First and
CBR,
second reagent, which name reaction
chemistry.
is this?
I cannot remember this name reaction, ma'am.
Actually, it is a Corey-Fuchs
First,
reaction. You,
actually, it is a strong nucleophile, right? The
uh,
CBR4.
this is your homework. Please study mechanism for Corey-Fuchs reaction.
four,
Spelling, I think
four.
this is your spelling. Actually, its role is RCHO converts to R C triple bond C. Okay. Now solve
Okay.
this question. Your first product will be your alkyne. So D answer is correct. But second reaction is which type of cycloaddition? As I have told you today that in today's class we will be discussing 1,3 dipolar cycloaddition.
Mm.
Okay. PHN3.
That means it forms a dipole, right? On the
Yeah.
boats.
Yeah. Whenever nitrogen is having four bonds, it will be having positive charge. Nitrogen is having two bonds, negative. Nitrogen having three bonds, neutral. You can easily draw
Mm.
this PHN3 structure, right?
Yes, ma'am.
You have alkyne. You have four partner, you have two partner. 4 plus 2 reaction between them.
Four.
This is your click reaction. Whenever there is 4 plus 2 cycloaddition between your between your azide and your, it can be either olefin or alkyne. This is known as name reaction, click reaction. Okay.
Click.
Now what
Okay.
you have to do? You have these dipoles. Here positive charge will come. It will look like this. pH N N double bond N negative. Can I write it like this?
Yes, ma'am. Yes. Then only it is 1,3
Clear
dipole.
now? Now you have to decide between this. You have this alkyne, right? Carbocation will be at
It
inside
forms a
side or
cyclo.
outside side. Can I write this group as R group? R dash, right?
Yes.
So
Mm,
R
mm, mm.
dash C triple bond C. You know that carbocation will be stable at inside carbon, and this will be
Sunset.
like this. Okay. So
Mm.
now positive will meet with negative. This I am saying so that you
Once a
can make correct
cyclopentane.
regioisomer. Huh? And this I will make here R1. Now just remove these charges and you are done. And this is nothing but your dipolar cycloaddition. Easy na? So this is your final
Yes,
product.
ma'am.
But one mistake we have done is since it was alkyne, so it will be having double bond. Where? Here. Right?
There are two types of 1,3 dipole, ma'am. Right? One is having triple bond and one is having double bond.
Yeah. It can be a triple bond either as your olefin. Simple double bond.
Mm.
Clear?
Okay.
This question is clear?
Yes. Yes, ma'am. Yes,
Very
ma'am.
good.
It is
Very
clear.
good. But you please read the mechanism for this Coriolis reaction.
Sure, ma'am.
Okay.
Sure. Hold it.
Actually, in CBr4 and PPH3, first it formed this. Then, in presence of excess N-butyl lithium, metal halogen
Mm.
exchange takes place. Okay, you
Okay.
read whole mechanism, then I will discuss in next class. Okay,
Okay.
then
Okay,
it
ma'am.
will
Sure.
be more clear to you. Okay, this is another example of your dipolar cycloaddition. You solve. I'm also solving along with you. Can I write it like this? O negative and C positive. Yes or no? You
Mm.
just
Yes,
have
ma'am.
to assign correct charges to those dipole, right? Once you know charges which will contain positive, which will negative, now your job is done. You have trans this. Again,
Trans.
reaction will be stereospecific. If they are trans in your olefin, they will be trans here as well.
Then it is trans.
Me, 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 double bond and oxygen. This will be your product in case of first. So this is in which option? This option I can delete. This option I can delete. No, no, no. Okay,
So
only
it
this
is not.
option I can
Yes.
delete. Among A, B, C, this option I can also delete. Among A and B, now tell me. These are same, right? Like this.
Yes, ma'am.
Now tell me the role of H2 in presence of nickel.
It is a reduction reaction, I think so.
What reaction?
It is used to reduce.
Uh,
Whenever we put
Actually,
catalytic hydrogenation, right?
NO bond cleavage. H2 nickel helps in NO bond cleavage. It just give HH
Okay.
both side, right? So first what you will get? Me
Mm.
double bond NH and here OH. Now H2O is also given. Yes or no? Imine will hydrolyze to your
Yes, ma'am.
ketene. Sorry. Imine will hydrolyze to your ketone. So your B answer is correct. Clear?
Correct. Yes, ma'am.
So it is 1,3 dipolar cycloaddition followed by subsequent functionalization. Okay. I hope this is last. Okay, not last. Tell me this question. It is also from your 1,3 dipolar cycloaddition. So dipolar cycloaddition is very easy actually. There is no such role of stereochemistry. You just have to see whatever olefin stereochemistry. If it is cis, you have to make cis in product. If it is trans, you have to make trans in product. That's all. Okay. So this is all about your dipolar cycloaddition. You can take this question as your homework. Okay. Very easy question.
Okay,
We
ma'am.
will discuss in next class. Just this arrow is for retrosynthesis. Retro you means okay. Do you know what is retrosynthesis? You have to go back.
No, ma'am.
Retro means
Mm.
old days. Okay. So they are asking how can you make this product by using this cyclopentadiene? Could you think of any path? Okay, if I will give you one hint, can you please give one try to this question? Let me give you one hint. Student, if you are given, okay, sorry, if you are given cyclopentadiene, okay, and you are given one olefin, you will get this product. This is only hint, not solution to this problem. Now, if I have done ozonolysis, ozonolysis will cleave this bond, right?
Yes, ma'am.
And you will get this. And if you see 1, 2, 3, sorry, not we will not count from here. 1, 2, 3, 4, 5. This is nothing but your 5-membered ring. Number it like in a same way 1, 2, 3, 4, 5. And at what carbon CHO is attached? At carbon number 1 and at carbon number 3. Yes or no?
Yes, ma'am.
So I have given you hint. Now can you think of CHO will reduce to CH2OH by LAH, lithium aluminium hydride. Can you tell me one reagent which can convert OBN into OH? H2PDC, right? I think now it's enough hint for this question. Now tell me how can you make? Are you solving or should I start explaining this?
I'm just trying, ma'am.
Okay,
Just
try,
give
try,
me a
try.
minute.
Take your time. Take it.
Ma'am, we have to go back, right? From the backward, we have to go.
Yes. Actually, huh. You have to tell me how to start synthesizing this compound. This. You have to tell me
I
starting
think,
material. You have to go back. Yeah.
yeah, first we have to convert the CH2OH into CHO, that aldehyde group. Is it right?
Okay, okay. You are. I think you are not get. You have to form this compound starting from this. Okay.
Oh,
You
okay.
have
Okay.
to go
Hmm.
like this. You have to make this
Okay.
compound starting from this. Now think.
Hmm.
You will feel good. You just think in same direction in which I have given you hint. I have told you
Okay.
reagents to
First,
convert also. You just have to
yeah,
take correct diene and take correct dienophile. This is very interesting question.
first we have to add PDC catalyst, right?
Okay, in first case only you will add
Uh,
PDC.
hmm.
No. First first you have to do Diels alder reaction. Okay, 4 plus 2 cycloaddition between your cyclopentadiene and olefin. Can you take cyclopentadiene is ready? You can't change, but you can change this, right? If if I take
Yes.
olefin with 2 CHO, you will be having 2 CHO here at 5 and 4. All these
Yes,
position
ma'am.
will be occupied. Yes or no? So what you will get,
Yes.
CHO, CHO, and at bridge CH2OBN, right? Now if I will do ozonolysis, this bond will cleave, and what I will get? CHO, CHO,
CH2.
CHO, CHO, and at bridge carbon CH2OBN.
OBN.
Yes or no? Everything is clear?
Yes, ma'am.
Now
Yes, yes.
just simply do LAH. All these will be converted into CH2OH, yes? And at last
CH2OH. Yes.
H2PDC, and you will get this product.
PDC. Okay, ma'am. Okay.
Nice question, na? So in
Yes,
this
ma'am.
way
Yes,
you
ma'am.
have to think how you have to draw this
Actually,
product.
it is quite different.
Huh. Now you can ask me doubt from today's class. This was all about today's session. We have discovered enough problems on desolder, mixed problem on electrocyclic as well as desolder, plus 1,3 dipolar cycloaddition. Okay, good. If you have
Okay.
any doubt from any slide, you can ask me.
Ma'am, I don't have any doubt on its slides because
Okay.
I cleared that one. And I have a doubt in one question, ma'am. If I have
Okay.
cyclopentadiene, then
In
how can
you
we
are
do the
asking in
reaction
general
in
doubt
the
or
room?
in any slide?
No, ma'am, general doubt.
Okay, ask.
Cyclopentadiene, ma'am,
Hmm.
the initial reactant, at room temperature, and what kind of product will be produced?
You have cyclopentadiene along with what?
Nothing, ma'am. It just left at room temperature. Then uh, I think 2 moles of cyclopentadiene.
Okay, you are asked. Okay, then it can undergo 4 plus 2. One
Hmm.
component will behave as diene and another component will behave as your dienophile. Understood?
Okay. Okay, ma'am.
Good question. Yeah.
Okay. Yeah, that's it, ma'am.
Actually, it will depend. If you are giving photochemical
Okay.
condition now, then 2 moles of it will undergo 2 plus 2 cycloaddition. But if you are giving it
Okay.
thermal condition, then it will undergo 4 plus 2 cycloaddition. Yes or no?
4 plus 2. Okay, ma'am. Okay.
Yeah. So thank you for joining the class. Okay.
Yeah, ma'am. Thank you so much, ma'am.